Good morning, good afternoon, good evening, wherever you may be. Thank you so much for joining us for this digital breakout session, how Lockheed Martin is advancing spaceflight with mixed reality. My name is Matt Fleckenstein. I'm the Senior Director of Product Marketing here at Microsoft, responsible for mixed reality. In just a little bit, I'm going to have a great colleague of mine, Shelley Peterson from Lockheed Martin, join us. And we're going to have a lively discussion around how Lockheed is leveraging mixed reality to really change the way that they work. But before I invite Shelley to join us, I want to spend a few moments sharing some of what we're seeing at Microsoft to give you a little bit of insight into where mixed reality is driving significant ROI and value today. I think we can all agree that cloud computing is arguably the biggest secular trend in computing over the last decade. It's fundamentally changed how we build, manage, and deploy our applications, and it's really been essential to letting every company become a technology company. And while cloud computing has gotten us most of the way there, it simply can't overcome the law of physics, such as the speed of light. As more and more people are connected online, and billions of devices get connected online, there's a need for ultra-low latency computing at the edge to enable the next generation immersive experiences. And that's never been more true than today, in this world of mixed reality where ubiquitous computing at the edge blends and transcends the physical and the digital worlds. If you go back to the 1970s, computing really started with mainframes when business users were literally tethered to a terminal at their desk. In the 1990s, gave rise to the era of personal computers and eventually laptops, which gave us some level of computing mobility for the very first time. But that promise wasn't really realized until the 2000s, when smartphones came into being. And for the very first time, we had the power of a computer in our pocket to take with us anywhere we wanted. And additionally, we got to understand the importance of contextual awareness, things like location, as we navigated through the world. All of that pales in comparison, though, to what we're witnessing now in this era of mixed reality. By blending the physical and the digital worlds, you really get to this notion of ubiquitous computing for the very first time. A computing experience where instead of looking at your screen, you're heads up, hands free, looking at and interacting with the world, overlaid with digital content. In this world of mixed reality is having a fundamental impact on transforming how we work. Let's take a look. They are the first line, a global workforce 2 billion strong. The first to see the product take shape, the first with the opportunity to address an issue, the first to touch customers, getting an understanding of their needs, and the first to create a lasting impression on their hearts and minds. Examples include call center reps, field service personnel, production workers, maintenance workers, retail clerks, and healthcare providers. In this time of digital transformation, their potential can be unlocked with mixed reality in whole new ways. They can be more connected to data, to each other, and to your customers than ever before, given more opportunity to grow their skills and thrive in their work. And at 2 billion strong, they can meet customer needs at an even deeper level. They can tap into each other's expertise and become even more efficient. But these 2 billion first-line workers have largely been left out of the digital transformation era. And there are some very good reasons for that. Oftentimes, because of where they work, they're disconnected from the team and the headquarters. They've got many outdated and obsolete tools and processes. Because you're deploying technology at the edge, there's oftentimes uneven security practices and governance. They require bunches of new training and upskilling and onboarding. They're slow to receive information. And of course, we've got a multi-generational and diverse workforce, many of whom are now at retirement age, which leaves you with a bunch of historical knowledge and expertise walking out the door. And mixed reality creates a game-changing opportunity for these 2 billion workers. For the first time, digital information and assets are being overlaid onto the physical world, bringing real-time data and insight to the front lines where they're performing their jobs. And it's doing it in a way that's heads up and hands free, enhancing their work, not disrupting it. So I just spent some time talking about the importance of first-line workers and the impact that mixed reality can have on digital transformation efforts. But I want to talk a little bit about the broader mixed reality market opportunity. The global mixed reality market opportunity is about a $6 billion opportunity today, growing to $34.3 billion by 2025, a staggering 41.3 compounded annual growth rate. If we look at today's market, it's largely comprised of two segments: consumers and then enterprise customers, specifically those first-line workers we were talking about. The vast majority of the market, as you'll see, is made up of consumers today, primarily dominated by VR device sales and gaming. But we're seeing this emergence among these first-line workers, growing from a $1 billion opportunity today to about a $9 billion opportunity by 2025. What you'll also notice as we move out 5 years from now is the emergence of another enterprise segment, information workers, individuals who spend their days sitting behind a desk, who will benefit from the power of mixed reality for things such as collaboration scenarios, virtual meetings, and design reviews. However, as I mentioned, the large enterprise opportunity today is really with those first-line workers. We talked about the power of that $2 billion strong workforce. And you can see, not only are they actually making up a big portion of the marketplace today, they're highly concentrated in a number of key industries. Discrete and process manufacturing make up the bulk of this market, but architecture, engineering, construction, retail, and healthcare are also fueling the mixed reality market today. And among those industries, there's really 6 primary use cases that we're seeing emerging in mixed reality. These are really the use cases being adopted by enterprises across many different industries all over the world, primarily because they have a very fast time to value and a significant proven ROI. These 3 across the top are where we see the majority of mixed reality opportunity today: training and simulation, educating and providing continuous learning for your employees, upskilling your existing employees, onboarding new employees, using a learning by doing approach. Guides and task management, walking employees step by step through self-guided experiences to complete specific activities, tasks, or assignments in real time. And then remote assistance, a very powerful scenario that we're seeing heavily adopted in today's world where travel is more and more difficult. Enabling your employees to remote in an expert anytime they need it, wherever they are. And it's not just remoting it in as a phone. Those who are actually participating in the experience remotely can actually see what the person's seeing through a HoloLens and actually engage and interact with and annotate the same content that you would be able to see as if you were there on site. And then these 3 across the bottom are really emerging opportunities that we're seeing starting to take off in the market. Things like designing and prototyping, converting your CAD and your BIM files to 3D digital twins to really quickly iterate and collaborate on new product designs. Sales assistance, enabling you to carry less inventory and close sales faster using mixed reality to demo any configuration or customization to your customers. And then this final one is a broad category around contextual data overlay, enabling your employees who are in the front lines to move faster and make more informed decisions by having pertinent real-time IoT data at their disposal, overlaid on top of the real world. To make this all happen, we've got a rich set of mixed reality offerings. At Microsoft, we've really focused on building a comprehensive mixed reality stack that all starts with the power of Azure. Our Azure mixed reality services enable developers to build applications and rich immersive experiences without having to tackle some of the most difficult problems that we've taken on by providing these services. Things such as allowing you to render high fidelity, high quality, high polygon count 3D content at the edge on a mixed reality device without decimation, made possible by our Azure Remote Rendering product. Or Azure Spatial Anchors, which enables developers to build applications that can map and persist 3D content to anywhere in the physical space. Or our newest service, Azure Object Anchors, which is just going into private preview now, which enables developers to anchor and persist content to physical objects in the real world. These past services, coupled with our extensive application development investments, leveraging middleware providers such as Unity and Unreal, which are the well-known established players for creating 3D content, coming originally out of the gaming space, all leveraging the power of Azure and our own mixed reality toolkit, which provides rich libraries and components of many common used toolsets and frameworks to make it easy to get started building your mixed reality applications. Because of these investments, we've really been able to build a very large and vibrant ecosystem of mixed reality applications, both our own first-party Microsoft Dynamics 365 mixed reality applications, as well as a whole ecosystem of third-party partners and ISVs who are building on top of our stack. And all of this, can render these rich experiences across a wide array of mixed reality endpoints and devices. For us, at the heart of those devices is, of course, HoloLens 2, the most comfortable and immersive mixed reality device available, all leveraging the reliability, the security, and the scalability of Azure. And on top of this world-leading device is this rich set of ISVs who have built out the largest ecosystem of enterprise-ready mixed reality applications in the world. Across nearly any use case, serving almost any industry, we've got a rich set of solution providers ready to help you enter into the mixed reality space today. I want to tell you a little bit more about one of our partners, Scope AR, and their WorkLink product. Together, that offering, our HoloLens device, and our full mixed reality stack are helping Lockheed Martin to send astronauts back to the moon in 2024. As you can see in the images here on the screen, you see a picture of the Orion spacecraft, which is at the heart of that mission. You'll also notice lots of little colored dots. Those little dots are signifying specific places where certain fasteners need to be applied. The mixed reality product, WorkLink, is helping those assemblers to identify exactly where those fasteners need to go, and the color coding indicates exactly which fastener needs to go where. It sounds like a pretty minor deal, but when you actually hear the story of Lockheed Martin and the ROI and the impact that it's having, I think you'll be quite amazed. But rather than me tell you about it, let's take a look at this quick video.
So imagine, you're crawling inside a spacecraft and you're trying to do the work. The last thing you need is to have to carry paper or tablets or laptops into the environment. Being able to have the data readily available without having to hold on to anything is significant. I'm Shelley Peterson. My role is Principal Investigator for Augmented and Mixed Reality at Lockheed Martin. We work with Orion, which is NASA's spacecraft that will take astronauts out to the moon and even into deeper space, such as Mars. On the Orion spacecraft, there's 57,000 fasteners. And normally the technicians would have to measure to know where to place those fasteners. With mixed reality, they put on the device, they see the digital version of the fastener hovering over the surface, they know exactly where to place it. When we do this, we save about 90% of the touch labor. We take an 8-hour activity of marking locations, and they finish it in 45 minutes. Or an 8-shift activity they can complete in 6 hours. It also reduces the potential for errors because the instruction is just so clear when they see it overlaid on the structure in front of them. Over the last 2+ years that we've used the HoloLens on the shop floor, we haven't had one error, and that's significant. It's just pretty powerful. It takes what we think of as a laptop or computing to the next level. Feels like magic.
Look, I told you, those little fasteners were going to be a big deal, and I knew that you'd enjoy that story. But rather than hear more about it from me, why don't I invite Shelley Peterson out to come tell you a little bit more about it? Hey, Shelley, it's great to see you again. Why don't you start by maybe introducing yourself?
I'm Shelley Peterson. I'm the Principal Investigator of Augmented and Mixed Reality for Lockheed Martin.
Hey, Shelley, I oftentimes tell people that I've got the coolest job in the world. But I look at your job. You've got augmented and mixed reality. You've got spaceships. What more could you ask for? Why don't you tell us a little bit more about what it is that you do at Lockheed Martin?
As a principal investigator of augmented and mixed reality, we're looking at augmented reality and mixed reality technologies, how they could benefit our programs. We shape the technology so that it meets our program's requirements and challenges. We deploy those solutions out to the programs so that we can produce spacecraft at lower costs with higher quality.
Hey Shelley, at the end of that video earlier, you talked about how HoloLens and mixed reality feels like magic. I've got to confess, to me, the Orion spacecraft feels a bit like magic. Could you tell us a little bit more about it?
So the Orion spacecraft is a NASA spacecraft. It's the only spacecraft that is designed to take humans into deep space, like the Moon and Mars. Orion is the spacecraft that will take the first woman and the next man back to the Moon. So Orion is a unique spacecraft that has taken a while to develop. It's been in development for a while, but we're at this exciting point where it's about to go into production.
Hey Shelley, I know Microsoft and Lockheed have been partnering for a while now in the mixed reality space, and you guys have taken full advantage of our mixed reality stack. And I know that you've been using HoloLens for quite some time. I'd love to have you tell us a little bit more about exactly what you're doing with HoloLens, and maybe a little bit about the journey that you went on to get to where you are today.
So we started using HoloLens in about 2016. We're using the HoloLens 1. We started using the HoloLens on the shop floor in 2017, the fall of 2017, looking at manufacturing processes on Orion for the forward bay cover. That activity, it was drilling activities where they would use the HoloLens to supplement the additional data that they had. They used the HoloLens for torque applications, for running torque, all of the details that they need in order to fasten the panels to the structure. Then we progressed into using the HoloLens on the heat shield and the full assembly of the heat shield, bringing a 1,600-hour activity down to about 1,000 hours. Then we found that we could use the HoloLens to know where to place objects on the structure. Things like fasteners and strain gauges, and heaters and thermistors, we could place with accuracy.
Thanks, Shelley. It's really fascinating to hear the history of how Lockheed Martin has been an early adopter of mixed reality and our HoloLens product. As I mentioned earlier, we have a rich ecosystem of enterprise-ready ISV applications that are really designed to serve any industry and a wide variety of use cases. I loved hearing the story about how Lockheed Martin has really evolved how they've used HoloLens and our mixed reality stack to meet many use cases in many different aspects of your business. I know one of those ISV partners, Scope AR, has been with you since the early days on this journey. Why don't you tell me a little bit more about your partnership?
We use the Scope AR WorkLink platform to build the augmented reality content that we use on the shop floor, which also has elements of Azure mixed reality integrated. Scope AR has shaped their technology in order to allow us to build the scenarios much more efficiently. For many of our activities, we can build the AR content in about 30 minutes, 15 to 30 minutes.
So we had a chance to talk about the important role that HoloLens 2 is playing at Lockheed Martin and how it's helping to create a new reality for work. And of course, that partnership with Scope AR seems incredibly strong. And it's amazing to hear the progress that you guys have made together in really making it quite easy and simple to produce content to train the next generation of workers. One area I'd like to dig into a little bit more, though, is the role of Azure and our mixed reality services in the work that you're doing at Lockheed Martin. At Azure, we're developing a suite of mixed reality services to assist developers in building mixed reality applications. Two of those services, spatial anchors and object anchors, are all about anchoring 3D content into the real world. Our spatial anchors product lets you map and persist 3D content to physical spaces. This is really the backbone of sharing and collaborating on 3D content. Much as you would with a physical object, you want to be able to place 3D content on a tabletop or in a specific location and let your colleagues see it exactly the way that you're seeing it. And you want that content to still be there when you show up the next day. Object Anchors is our newest service. It just came to market here at Ignite as we announced private preview. Whereas Spatial Anchors lets you map 3D content to physical spaces, Object Anchors is all about aligning 3D content to physical objects.
Yeah, so with mixed reality, with the depth sensors and the knowledge of the device, it understands the environment. So we can overlay the content directly onto the structure. It's anchored to the structure, and that allows us to place content within the environment. That combination becomes very powerful. We can animate the environment. We can show specifically the instruction very quickly, very clearly to a technician who may be very new to that position.
Shelley, I know anchoring is a concept that you're quite familiar with at Lockheed Martin. Why don't you tell me a little bit about some of the work you have going on in that arena?
We have really skilled technicians and engineers, but it becomes even more powerful when they can communicate with each other. When a technician is working on the shop floor and they have a question, they can call out to a subject matter expert with a tablet. So having that collaborative communication from the technician to an engineer allows us to move more quickly in solving the challenges and helping them continue with their work effort. We also have scenarios where the engineers need to collaborate on a design, and being able to see the same design together, being able to envision the structure that hasn't been built yet and look through different options allows us to make those decisions more quickly.
Hey, Shelley, before I let you go, I want to ask the question that everyone's wondering about. Do all these investments in mixed reality really pay off? Let's talk numbers. What kind of ROI are you seeing at Lockheed Martin?
So at Michoud, we had 2 to 3 technicians working for 2 to 3 shifts, marking the locations of 309 click bonds. When we use mixed reality, we can do that same work with 1 technician in 2.5 hours. Now that's a 93% touch labor reduction. And so we started to use that same type of use case and technology at other sites and other areas of the Orion program. And what we found was that we could take an 8-hour activity and reduce it down to 45 minutes, marking strain gauges on panels. We could take an 8-shift activity, marking locations of click bonds inside the Orion structure. We could bring that down to 6 hours. Each one of those is a 90+% reduction in touch labor, and we've seen that consistently over the last several years. We're also able to take standard work instruction, step-based work instruction. We can reduce touch labor by about 35 to 50%. And in the 3+ years that we've been using mixed reality on the shop floor, we haven't had a single error that's been documented while we have AR, MR in use. It's exciting to see the effect of mixed reality on the programs.
Hey, Shelley, on behalf of myself and all of us at Microsoft, as well as all of those who have tuned in and listened, I want to say thank you for sharing the Lockheed Martin story and for telling us all about how you're leveraging the power of mixed reality to send astronauts to the moon and beyond. I hope that all of you who tuned in enjoy the rest of Ignite. Thank you very much.